Hi. In the in the exercise just before the video, I asked you to make a SR latch with NAND gates instead of with NOR gates. And if you had done that exercise, you should have gotten a result like this. So this is the SR latch with an AND gate, and this is the truth table of the SR latch. You can see that in this case, 1 1 is the memory condition, while 0 0 is the kind of the not allowed condition. The reason why we don't want to allow it is because you want the outputs to be opposites of each other. That's why we have named them q and q bar, right? So in all these cases, you can see that the outputs are opposite of each other, and the condition is only not met when S and R are 0 and 0. In this case, Q and Q bar are 1 1. They are not opposites of each other. So let's call this the not allowed condition. So you are not allowed in this SR latch to give S equal to 1 and R equal to 1. Okay. Okay, so let's use this SR latch to build what is called an RS flip-flop. And let's do the building first, and then I'm sure you'll see uh, uh, what is the difference between an SR latch and an RS flip-flop. Okay, so the way to build the RS flip-flop is to put NAND gates at the inputs of the latch. So I put a NAND gate here, and I put an AND gate here at the input. Okay, and one of the inputs to the NOR gate is a common input, and that's called a clock. And this input is S, and this input is R. Let's call these intermediate S and R as S bar and R bar, just for making it easier for us to analyze the circuit. Okay, so now let's write the truth table for this RS flip-flop. So the three inputs are S, R, and clock. You can talk about an intermediate outputs S bar and R bar, intermediate states, and then you have the final outputs Q and Q bar. Okay, and let's start off with the case when the clock is 1. Okay, so what happens when the clock is 1? So if I say that the clock is 1, I have four combinations of S and R, right? 0 1, 1 0, and 1 1, and in all these conditions I have the clock as 1. Now, before we take a look at this circuit, just try to remind yourself how a NAND gate works. A NAND gate has an output of 0 if, sorry, it has the output of 0 only in one condition. That is when both the inputs are 1. If there is any other condition, so for example, if any one of these inputs is 0, then your output is going to be 1. Okay, that's how a NAND gate works. So let's then look at the truth table here and see how this would work. So the case when both NAND gates are going to give an output of 0 0 is what? Is when you have S and R and the clock all ones. So in that case, the inputs to both these NAND gates are both ones, and so you get 0 0 here, right? So you get 0 0 here as S bar and R bar, and you can see from this table that you will get Q and Q bar as 1 and 1. So you get 1 and 1. And as we said, this is kind of the not allowed condition, so we don't want to allow this condition. So let's just cross this out just to show that this is a not allowed condition. We don't want S, R, and clock all to be 1 at one time. Okay, now what happens at the other stages? So let's look at, for example, this condition. So S is 1, the clock is 1. So if S is 1 and the clock is 1, S becomes S bar, S prime becomes 0, right? Now, on the other hand, if R is 0 and clock is 1, so this R is 0 and this clock is 1, what is going to be the R prime? R prime is going to be 1. So R prime is 1. And then we can look from this table that for S and R equal to 0, 1, we get Q and Q bar as 1 and 0. Okay, so you get Q as 1 and Q bar as 0. Is that okay? And similarly, I think I'll leave you to do this, but for this condition, you should get Q and Q bar equal to 0 and 1. Now let's look at what happens when S and R are both equal to 0. So S is 0, R is 0. If S is 0 and R is 0, what do you get? S prime and R prime both are 1 and 1, right? Both are 1 and 1, and that corresponds to this particular condition. So your outputs are Q and Q bar. So you get Q and Q bar. So essentially, when the clock is 1, this circuit behaves almost exactly like SR latch. There's slight differences, but not too many, right? It's almost similar. So, uh, okay, so what happens when the clock is 0? So when the clock is 0, take a look at this. When the clock is 0, both the outputs, whatever the values of S and R are, the outputs here is always going to be 1 and 1, and therefore you're always in this Q and Q bar condition. So your outputs are always going to be Q and Q bar. So because this is 1 and 1, and it doesn't depend on what S and R are. Okay, so how does this circuit function then? We have written the truth table. Now let's just step back and think about how this circuit works. So what we are saying is, this circuit, in addition to the R and S inputs, has a clock input, and the circuit only responds to the R and S inputs when the clock is 1. If the clock is 0, whatever the previous state is, that is maintained at the output, right? Only when the clock is 1 is S and R able to change the output. Does that make sense? So the inputs only affect the output when clock is equal to 1. The inputs don't affect the output when the clock is 0. So in one sense, the clock is acting like a gating signal, right? It is gating the inputs from affecting the outputs. So these kinds of circuits, okay, these kinds of circuits where there is a kind of a gating signal, a timing signal, which uh, controls whether an input can influence an output or not, these kinds of circuits are called uh, synchronous circuits, right? Let me just write that here. So these are called synchronous circuits. The reason why they are called synchronous is because the circuits, the inputs influence the outputs, and the time for the influence is synchronized to the clock signal. Okay, there is another type of sequential logic called asynchronous circuits, and the SR latch is one example of it, where as soon as the input changes, it influences the output. So that's called an asynchronous circuit, right? Because it's not synchronized to any clock. But here, the working is synchronized to a particular clock, and we'll see why that is important in a moment, in the next few videos. Hopefully, so basically the RS flip flop and the SR latch are very similar in function, other than the fact that RS flip flop is a synchronous circuit while an SR latch is a asynchronous circuit. Okay, let's stop here and we'll continue in the next video.